So today we will be discussing the data transfer schemes which are used in 8085. We know that data can be transferred in 8085 is concerned. Data can be transferred in between microprocessor and the memory, microprocessor and input output device, and memory and input output devices. So in microprocessor based system, the data transfer takes place between two different devices, such as microprocessor and memory as mentioned, or microprocessor and input output devices, as well as the memory and the input output devices. Now, as far as the memories are concerned, it is made up of semiconductor devices. So we can call it as a semiconductor memories. And these semiconductor memories are compatible with the microprocessor because the same technology is being used in the manufacturing of both the memories as well as the microprocessor is concerned. So it means there are less problem which is associated if we want to interface memory with the microprocessor. But as far as the input output devices are concerned, whenever they are required to be interfaced for actual data transfer, we have a wide variety of input and the output devices having wide range of the speed, as well as they are having different characteristics also. So it may be possible that the different input and output devices will be using different manufacturing technology. It may be electronic, it may be electrical, it may be mechanical, it may be electromechanical, it may be optical also. So due to these reasons, the interfacing designer is going to face difficulty in interfacing the input output devices with the microprocessor. So it means for interfacing the memory with the microprocessor is not a problematic because of the same technology is being used for manufacturing of both, but special interfacing devices are required to be designed if we want to transfer the data in between the microprocessor and the input output devices. Now, in any microprocessor based system, it may have different kinds of input output devices having different speeds. It may be slower input output devices. It may be quite good speed input and output devices. So as far as the slow input output devices are concerned, they are able to transfer the data when the microprocessor is going to issue the instruction for the same. So that it may be taking some time to get ready. So to solve this kind of problem because of the mismatch of the speed in between the microprocessor and the input output devices, there are a number of data transfer techniques or the schemes which have been developed. So the different schemes which are required to interface the processor with the input output devices, we have two broad categories. One is known as program data transfer scheme, and another is a DMA data transfer scheme. Now let us go and find out what is the detail about the program data transfer scheme and DMA data transfer scheme. So first of all, program data transfer scheme. Now, as far as the program data transfer scheme are concerned, it is controlled by the central processing unit. So the data are transferred from an input output device to the microprocessor or to the memory through the CPU or vice versa. If we want to transfer the data in between from the input output device to the CPU or from the CPU to the input output device or from the input output device to the memory through CPU or from the memory to the input output device through the CPU. So the control of the program which is required to transfer the data, it usually resides in the memory. So whatever program which resides in the memory, it is required to be executed by the CPU when the input output device is ready to transfer the data. Now the microprocessor executes the program to actual transfer of the data, because until unless the program is not executed, the data transfer will not take place. So the program data transfer schemes are employed when we have a small amount of the data to be transferred. And the program data transfer scheme can be classified into three parts. One is synchronous data transfer scheme, asynchronous data transfer scheme, and the interrupt driven data transfer scheme. Synchronous data transfer scheme is a kind of a scheme. It is employed when the processor speed and the device speed is little bit same. And asynchronous data transfer scheme is used when the device speed is different from the speed of the microprocessor. And interrupt driven data transfer scheme is used whenever device wants to transfer the data through the interrupt. So we will discuss it later on. Let us go into the second category, that is DMA data transfer scheme. So let us understand what is DMA data transfer scheme. Actually, DMA stands for direct memory access. In DMA data transfer scheme, the central processing unit or the microprocessor is not going to participate, and the data are directly transferred from the input output devices to the memory, or from the memory to the input output devices. And this scheme is employed whenever we have to transfer a large amount of the data. Because why this scheme is used? Because we know that everything which is required for the data transfer, that is control bus, address bus, and the data bus, all these buses are under the control of the microprocessor. So whenever any device wants to transfer any data to another device, what it has to do, it has to take the help of microprocessor. First of all, the source device will send the data to the processor, and then from the processor, the data will be transferred to the destination device. But if we allow this kind of scheme, it will be very tedious and a time-taking process, because whenever we have to transfer a large amount of the data, this scheme is going to take a lot of time. So to solve this kind of problem, we have a scheme known as DMA data transfer scheme, in which the data can be directly transferred from one device from the source device to the destination device. And what happens in this, how it is possible to transfer the data from one device to another device? By requesting the microprocessor to allow the source device to use the control bus, the address bus, and the data bus under its control, so that once these buses are under the control of the source device, now these buses can be used to transfer the data from one device to the another device. So the data transfer, which is controlled by now the input output devices through a DMA controller. And this scheme is employed, as I told you, that this scheme is employed when a large amount of the data has to be transferred. So if bulk data are to be transferred, so since CPU takes some time to process, so the transferring is slow, and so the input output device which wants to send the data using the DMA scheme sends a hold signal to the CPU, and after receiving the hold signal from the input output device, the CPU gives up the control of the buses as soon as the machine cycle is going to complete. Whatever operation it is doing in the form of a machine cycle, it will first complete it, and then CPU sends a hold acknowledge signal to that particular device who has made a request by sending the hold signal, just to indicate, just to give the information that the processor has already received the hold request and it is going to release the buses. Now the buses will be under the control of the input output device. Now the input output device takes over that control of the buses and directly transfers the data to another device. It may be the memory or it may be the output device. So you can say that DMA data transfer scheme is faster scheme as compared to the program data transfer scheme, and it is used to transfer the data from the mass storage devices such as floppy disk, hard disk, pen drive, the compact disk. So it is also used for the high-speed printers also. So when the device is ready to transfer the data, it will first send the hold signal to the processor. First processor, while receiving this hold signal, whatever machine cycle operation it is doing, first it will complete it, and then once it becomes free, it sends a hold acknowledge signal to the so once the input output device who has sent the hold request signal and receives the hold acknowledge signal, and the actual data transfer takes place in between the source device and another device after that. And once this data transfer operation is over, it will again send a signal to the microprocessor, giving the information that whatever control has been given, allotted to that particular device, the work is over. Now you can do your work. So in that case, the microprocessor will be able to regain the control over the buses and it starts its operation. So that is the two data transfer schemes. One is program data transfer scheme and the DMA data transfer scheme. Now, this is the illustration by which you can see that how the address bus, data bus, and the control bus is used to transfer the data in between the memory and the input output device. Now, in general, whenever we have to categorize the different data transfer schemes, it depends upon many things. There are certain parameters based on which the data transfer schemes can be classified. The first parameter based on which the data transfer schemes are classified is the transmission format. And in this, based on this parameter, we have two kinds of data transfer. One is called asynchronous data transfer, and second one is synchronous data transfer. Now, the meaning of synchronous data transfer and the asynchronous data transfer is very simple. Synchronous means at the same time, and asynchronous means at other time. Now, first of all, we will explain the classification and then we'll take the individual data transfer scheme. So based on transmission format, we have two schemes, asynchronous and synchronous data transfer scheme. Based on the modes of the data transfer, we have two categories. One is parallel data transfer and another is serial data transfer. In parallel data transfer, 8-bit of the data is transferred at a time. In serial data transfer, only 1 bit is being transferred at a time. Then we have type of input output, how we have recognized the input output devices, and based on which the data transfer scheme. We have two data transfer scheme. One is peripheral mapped input output and second one is memory mapped input output. In peripheral mapped input output, the input output devices are considered as a separate entity, not at all concerned with the memory. They are separate entities, separate address schemes are being used, and separate instructions, for example, in and out instructions are used for that. But in case of memory mapped input output scheme, we consider that input output device is a kind of memory device. So considering input output device as a kind of memory device, so all the operations which are being used, all the instructions which are used to transfer the data in between processor and the memory, these all instructions will also be used for transfer of the data in between processor and the input output device. So that is why it is called memory mapped input output device. Means the input output devices are mapped as the memory. And we know that in that case, in and out instructions are not used, but all those instructions which are used to transfer the data in between processor and the memory will be used to transfer the data in between processor and the input output device. Then we have conditions of the data transfer. The first one is the microprocessor controlled data transfer scheme, and another is device control. Now, the example of microprocessor control, I have just explained the processor based control, program data transfer scheme, and second one is DMA data transfer scheme, that is device control. So depending upon the condition of data transfer, we have two categories. One is processor control data transfer scheme, and another is device control data transfer scheme. Now, in processor based data transfer, we have many schemes. One is unconditional data transfer. Second one is pooling. Third one is interrupt driven data transfer. Fourth one is using ready signal. And fifth one is with the handshake signal. Handshake signal is again divided into two parts. One is a status check, and next one is the interrupt. And in case of device control data transfer scheme, we will be using direct memory access data transfer scheme with the help of the hold signal. So these are the categorization of the different data transfer schemes which are used in 8085 based on the parameters, transmission format, modes of data transfer, type of input output, and the conditions of the data transfer. So we are going one by one to explain each one. So first of all, the asynchronous data, synchronous data transfer scheme. Synchronous means at the same time, means the device which sends the data and the device which is going to receive the data are synchronized with the same clock. So when CPU and the input output devices are going to match in the speed, this technique of the data transfer scheme is employed. Meaning thereby synchronous data transfer scheme can be employed if and only if the processor and the input output device are working with the same clock in the same speed. Same speed means whenever a processor wants the data should be ready at the input output device, or when the processor is going to give the data to the input output device, it should be ready to receive the data. So this system is employed, means synchronous data transfer scheme, if the speed are going to match. Now the data transfer with input output device is performed by executing in and out instruction for the input output map input output devices, or using memory read and write instructions using the memory map input output devices. Now the in instruction is used to read the data from an input device which is connected with the input port, and the out instruction is used to send the data from the CPU to the output device or the output port. So as the CPU and the input output device are going to match in the speed, the input output device is ready to transfer the data when any in instruction or out instruction is being issued or executed by the microprocessor. Now, as far as the status of the input output device is concerned, the status of the input output device, whether it is ready or it is not ready, it can be examined before the actual data transfer took place, because it may be needed. It may be possible that the device may not be ready. So if you want the actual transfer of the data, it must be examined whether the peripheral device is ready to transfer or ready to receive the data or not. Usually this scheme is not preferred because there is no input output device which is compatible with the speed of the microprocessor. So that is why it is not applied in often. So it is very rarely used as far as whenever the processor wants to transfer the data with the input output device. However, whenever we talk about the memory, since memories are compatible with the microprocessor, so and they are always available, and the speed of the memory as well as the speed of the, I'm talking about the primary memory, semiconductor memory. And since semiconductor material, the microprocessor is also made up of semiconductor material, and memory is also made up of semiconductor material. So they are both are easily available to ready to transfer the data. So this scheme is normally used with the memory, especially It is used with the primary memory, semiconductor memory. Now, asynchronous data transfer. Asynchronous data transfer means at the irregular interval. So what happens in this particular method? The data transfer is not based on predetermined timing pattern. The timing pattern will be different. And this technique of data transfer is used when the speed of an input output device is not going to match with the speed of the processor. And the timing characteristic of the input output device is not predictable. For example, if we take the case of AD converter, the device known as AD converter, which is working as an input device. So what this device used to do, it used to convert the analog signal into the digital information. So, and it is a slower device. So whenever the processor will be in requirement of some data from the AD converter, it has to wait, because analog to digital converter is not so fast that it is ready to give the information whenever the processor is in requirement. So it has to wait. So for that particular kind of input device or the output device, we use the asynchronous data transfer scheme. In this particular technique, the status of the input output device, whether the device is ready or not, is required to be checked by the processor before the data has to be transferred. Because until unless the device is not ready and CPU is sending, or the processor is sending some data and device is not ready, the data will be going in waste. It will be lost. So the microprocessor is going to initiate the process of checking the input output device, and then once it get ready, it always going to check it every time whether the device is ready or not, Once the device is ready, then only it will transfer the data. So status has to be checked. So a kind of handshaking signal is exchanged before the data transfer, meaning thereby whenever the CPU wants to communicate with the device which is slower, so what it will do, it will always send a signal. And when the device will be ready, it will be sending a ready signal. So in this way, where it is going to check the status, and once the status is ready, the device will be exchanging the signal. Then this is called the handshaking of the signal, because handshaking requires two hands to come together. So once the status is being checked by the processor and sending the signal, status checking signal to the device, and once the device is ready, it will be sending a signal, just giving the information that it is ready now. So it means there is a process by which a handshaking is being done, then only the transfer took place. In this data transfer scheme, the processor is going to initiate by issuing a signal to get the ready or the start. And when the input output device is ready, it will send a signal to the processor about its status. Until it is not ready, it will not send the signal. And once it will become ready, so it will be sending the signal. Now the software approach uses the exchange of the signal, and the hardware approach uses the ready signal. So in this way, this is going to happen. Now this mode of data transfer, it is called handshaking mode of data transfer, because the signals are exchanged between the processor and the input output device before the actual data transfer. So you can say that asynchronous data transfer scheme is also a handshaking data transfer scheme. Now this is an example of handshaking signal which is exchanged in the asynchronous data transfer. This is the microprocessor and this is the device. So what microprocessor had sent a start signal, and when the device is going to ready, it will send its status to the microprocessor. Once it become ready, it will send the signal. So it means we have in exchange of these two signal, which is called handshake signal. Similarly, we have another, this is the input output device. This is another input output device, which is AD converter. So once the processor is in requirement of certain information in the form of a data, it will send a signal that is start the conversion. S/C means start the conversion. And AD converter starts the conversion of analog into the digital. Once it completes the conversion from analog to digital, it will send a signal back to the processor, that is end of the conversion. So it means two signals are being exchanged in between processor and the device, and that is why it is also called handshaking data transfer scheme. Now, the modes of the data transfer, the second category, that is the parallel data transfer scheme and the serial data transfer scheme. Now, in the parallel data transfer scheme, 4-bit, 8-bit, 16-bit is transferred at a time in one time in the parallel mode. For example, keyboard, LED display, memory, data converter. These all devices use the parallel data transfer scheme in which the bunch of the binary digits are being transferred at a time. But in case of serial mode of data transfer scheme, as I told you, it will transfer only one bit at a time. For example, CRT terminal, printer, cassette tape, etc. There are many examples of serial data transfer. So depending upon the type of the devices with which it wants to communicate, it used to use either parallel data transfer or the serial data transfer. If there are a device which is going to receive or provide the data only serial basis, we will be using serial data transfer scheme. But the device which is ready to transfer the data or receive the data in parallel, means 4-bit, 8-bit or 16-bit at a time, it will be using parallel data transfer scheme. This has been already explained that depending upon the type of input output, whether it is input output mapped scheme or it is a memory mapped input output scheme. In peripheral mapped, as told you that input output devices are identified by the 8-bit address, and separate instruction like in and out instructions are used for actual data transfer. But in memory mapped, we treat input output device as a kind of memory, and all those instructions are used. And even though since memory are represented by 16-bit address, so input output devices are also assigned a 16-bit address. So this is the difference in between these two. So it depends which scheme we are using. If we are using input output mapped scheme, then in that case 8-bit address and in and out instruction. But if it is memory mapped input output, then in that case 16-bit address and all those instructions which is used for transfer of the data in between memory and the microprocessor. Now, this has been already explained. One is microprocessor controlled, and second one is the device controlled. Now we have microprocessor controlled data transfer, and we have seen there are many categories of that. In microprocessor control, we have unconditional pooling, interrupt, ready signal, handshake signal, all. So we will discuss it one by one. So first is unconditional. Unconditional, in this form of the data transfer, the microprocessor assumes that a peripheral is always available. For example, if you take an example of displaying the data at the LED port, the microprocessor is simply enabling the port on which the LED device is connected, and then it transfers the data and goes on executing the next instruction. So it is unconditional, no need to check, directly transfer the data. Second one is pooling. Pooling means status check. In this form of the data transfer, that is called pooling, the microprocessor keep itself in a loop to check whether the data are available or not, device is ready or not. So this is called pooling. Pooling is a process in which the microprocessor will be checking every time whether the device is ready or not. Device is ready or not. If you take an example, if it wants to, processor wants to read the data from the input keyboard, from the single board microcomputer, the processor keeps on checking whether the key has been pressed or not. The key has been pressed or not. The key has been pressed or not. So this kind of is known as status check, or this is called the pulling. So keyboard is an example of pulling. Then we have interrupt driven data transfer using interrupt. So in this case, processor has to do nothing. It is free to perform other tasks rather than holding itself in a pulling loop. Processor is not required to check each time whether the device is ready or not, whether the keyboard has been pressed or not. It is free. It used to do its tasks. So what happens in the case of data transfer with the interrupt? In this condition, when a peripheral is ready to transfer the data, it sends an interrupt signal to the processor. Now the processor stops its execution of the program, accepts the data from the peripheral, and then return to the program, resumes that particular program which it is executing. So in this interrupt technique, the processor is free to perform other tasks rather than keeping itself in a pulling loop. Then we have another scheme which is known as data transfer with the help of ready signal. What does it mean? When the peripheral response time is slower than the execution time of the processor, the ready signal can be used to add the additional T states, thus extending the execution time of the processor. Means it keeps the processor in waiting by providing the ready signal. This process provides sufficient time for the peripheral to complete the data transfer. And this technique is commonly used in the system having the slower memory chips. There is a condition in which the memory chips may be slower. So in that case, we will be using the ready signal. Then we have data transfer with the handshake signal. Now, in this data transfer scheme in which we are using handshake signal, the signals are exchanged in between the processor and the peripheral before the actual data transfer took place. And these signals which are used to exchange are called handshake signal. And the functionality of the handshake signal is to ensure the readiness of the peripheral and to synchronize the timing of the data transfer. Now, if you take an example, when an AD converter, I have given you the example that AD converter is used as an input device, the processor needs to wait because the AD converter will take conversion time to convert the analog signal into the digital signal. And when it is going to end the conversion, it means the AD converter is ready with the data. So it sends a data ready or end of the conversion signal to the microprocessor. So when this end of conversion signal or data ready signal is being received by the processor, now it is going to read the data and acknowledges it by sending a signal to the converter that data have been read. Now during this conversion process, while AD converter is converting the data from analog to the digital, the microprocessor keep itself checking whether the signal has been sent, the data ready signal or the end of conversion signal has been sent by the device or not. So this technique is also called status check with the handshake signal. The status check method is functionally similar to the pooling method and achieves the same result. Now, in this scheme also, rather than using the handshake signal for the status check, the signal can be used to implement the data transfer using the interrupt also. In this example of the AD converter, the data ready signal can be a kind of an interrupt to the processor. But if we are using handshake signal, this handshake signal is going to prevent the data, the microprocessor, from reading the same data more than once from a slower device and from writing new data before the device has accepted the previous data. So every scheme has its own pros and cons, and every scheme can be applied depending upon the condition in which we want to transfer the data. That's all.